I'm with the government. I'm here to help, and I have all your solutions. Maybe not today, but hopefully in the near future. So I wanted to point out, I'm the program manager for Biomade, which is one of the Manufacturing USA institutes. It's the 9th Department of Defense Manufacturing Institute, and I won't spend too much time talking on it, but you can certainly hear me and my colleague talk about it on the Daily Digest with Jim Lane and other venues as well. We're certainly happy to give you some other updates. But I want you to shift a little bit your thinking and look into the future and what that crystal ball might look like. Biomade is the first biomanufacturing institute for non-medical manufacturing, and it is a whole ecosystem. So we're doing everything from the technology development to produce non-medical materials all the way down to conduct education workforce development, and as well as touch on the regulatory and the policy parts, because one of the biggest problems, especially in biotechnology and looking at biotechnology from a non-medical perspective and looking at it for material applications, is that companies see the regulations and the policies more of a burden than an opportunity. And that is one of the major charges that we're taking with this institute to move forward. So I want to start with having you rethink a little bit about what biology is. We always think that biology is something squishy, and yet biology has had eons to evolve to make materials that are stronger, more capable, more effective and efficient than we could ever imagine. And I don't need to give you too many examples of it. The problem with it has been we haven't been able to exploit it to the benefit that we would like to. And that's really the biggest problem at the moment, is that there is a burgeoning fourth industrial revolution, as the biotechnologists like to call it, in proof of concept stage, but it hasn't really matured to a technology space where you might be able to use it today. The goal is really to, with the right incentives, with the right efforts, similar to Biomade, meet that goal within the next 5 years. And some of the things that you were talking about today were quite interesting, but taking it another step forward, right? So biology can actually do a lot of the things that you have listed as challenges. And so that's why I was mentioning earlier, I think that we need to start thinking outside of the box a little bit and saying, well, it's not, we have the existing conventional materials to be able to make things, but we need to look outside of that space and also start doing the techno-economic analysis to contemplate what the opportunity is in that space. So if you look at, for example, something as plastics, as Per was outlining, there are groups, for example, in China who have engineered bacteria to leverage the same principle as brewing beer or fermenting wine to make different types of plastics, PHA and PHB primarily. And the input is sugar and water, and you have as your feedstocks. And certainly there's a challenge there to make sure that the plastic can compete in terms of price as well as performance. The benefit of these types of plastics as they're being refined, and you really have to think about biology as a more effective and efficient way of the petrochemical industry or the synthetic chemistry industry of delivering products, is that the plastics that, for example, the Chinese are now making in tonnage scale, they can shred, and they've shown now that they use it as feedstock to feed fish farms as well as hog farms as food, and they've shown great usage of the material. So you're starting to create a truly circular economy here. And so there are all these benefits of material that we need to exploit much better. The beauty of where we are with biotechnology at the moment is that engineering biology as a platform is leveraging material sciences and interfacing with material science to start speaking a language that the engineers, the manufacturers can start to understand. And so now you have companies popping up like Biomason who are actually growing cement blocks to be able to grow homes in defense, we're looking at that to grow runways. You still have some of the raw materials that you need to introduce to be able to meet that goal. So these are very early on processes, but the proof of concepts are there. If you look to Australia, there are lots of construction companies, because they are resource constrained and things, it's expensive to deliver raw materials, are looking to biotechnology to actually address the topic of making more of the construction material domestically, so that you don't have to worry about the cost, the footprint, and all the surrounding aspects of it, while still delivering a viable product. And so this field is really working towards being able to deliver a lot of these technologies. And if you explore the makerspace, you can see, you were talking about fireproofing materials. So there's an example of a molecule that comes from red wine, from the skin of grapes, actually, called resveratrol, that has as a polymer or as a thermal resin, can withstand temperatures up to 600 degrees Celsius and has a char yield of 85%. Making that at scale, you can see that that would be a fully biological solution to fireproofing commercial construction, very reliably and resource efficient compared to other materials. The key here, really, in thinking about this paradigm shift, is how we're getting to that point beyond the proof of concepts that I was just presenting to you. And I think this, and I'm very eager and interested to hear what Per has to say on this, is when you look at the cycle of leveraging biotechnology or engineering biology to make materials, the nice thing is that you can start with input from existing waste streams. So whether it's plastics, agricultural residues, biomass, different types, in the eyes of bacteria and yeast, these are all food sources. It's all carbon in various types of forms that can be used to feed the bacteria to make different things. And what engineering biology has enabled us to do is take really interesting materials, molecules, make synthetic precursors in biology rather than rely on the synthetic chemistry or the petrochemical industry, very effectively and very efficiently, to be able to meet some of the goals while delivering products that are at scale and at standard, or even exceed that standard. The other part to it is that now you have a makerspace that is far beyond the reach of our conventional thinking at the moment, is that you can now start making novel materials that have been too costly or too difficult to make, or even things that we haven't even considered a potential product for the market yet, because of the likes of advances with DeepMind and looking at biology, but also the combination of materials. So starting to make emergent metamaterials, of combining different things together, like plant fibers, like other biological from the fauna, from animals, with existing materials to make them stronger and better. The fourth part, really, to this paradigm shift is thinking about manufacturing. Bio-based manufacturing does no longer require the footprint that you would look at from a petrochemical industry perspective or from a synthetic chemistry industry perspective. The footprint is much smaller if you're thinking about your craft brewery, your local craft brewery that is able to make the material, because you're using the same concepts as these craft breweries are, except you're making molecules of interest. And so you no longer have that labor-intensive or energy-intensive development costs to be able to deliver the materials, and so they can economically be a little bit more interesting than what we are used to at the moment. And here you just can see a couple of examples of what the opportunity space is and how we're going to get to that space. And I think there are certain things here that you can see that we're working towards as a community as a whole. But the problem is that the industry doesn't necessarily appreciate biology as that opportunity in the first place. So you have groups who are, for example, taking different types of energy inputs and turning them into protein through the chemical processes. You're recycling rare earth metals. And this is also really interesting in terms of creating a domestic resilient supply chain, is that other industries such as the petrochemical industry or the synthetic chemistry industry rely on the cost of what a barrel of oil is. And we can see this currently, for example, with our shortages in personal protective equipment. The production mostly is relying on the lack of fine chemicals. So that is a result of oil industry drawing down their oil production from crude oil, because their biggest economic driver is fuel. And since there's such a low demand, all of these other products, fine chemicals, high value chemicals, are just not being made to the level that they need to be made. And so we're in a difficult position. With biology, using biology, we could turn waste streams that exist already today, and we're struggling to figure out what to do with them, use them as feedstock. So you turn them into valued resources, feed the bacteria with it, and then make these fine chemicals or high value chemicals that you actually desire. The other part to this is that this can be a distributed system. So looking at the footprint, of what was presented earlier, that a lot of the cost in terms of environmental footprint is actually the movement of the material. You could set these up all across the US and leverage the local waste streams, whether it's food waste, whether it's agricultural waste, right? So moving to the East Coast for switchgrass, looking to the central states for sugar beets, you can use these different waste stocks to actually feed the material, feed the bacteria to make the material that you want. And so you're creating that circular economy where you might not get to a full zero carbon initiative, but you're very close to that, because biology has evolved to figure out that every input has to go to some kind of an output. So their net zero process is bar none. We certainly can't do this alone. This fourth industrial revolution that I was talking about is primarily driven all around the globe outside of the US, because countries value and look to biotechnology as an opportunity space. We still have challenges. There's a lot of concern or negative press around genetically modified organisms and their application space. And so we struggle to see products that you see as novelties come on the market, such as the Adidas spider silk shoes that are made completely of spider silk, be actually novelty products and not standard products that you can find in your local store for purchase. But the performance and the technology is available to do it. It's just a matter of getting it into the market space to deliver. On the left side, you can see a concept for a prototype where you have a modular production system where you use bacteria that use food waste, local waste, and then produce all different types of fuels that meet or exceed current standards in fuel quality. That would be a surrogate, a direct drop-in for existing petrochemical fuels. And this is not a biofuel, this is biomanufactured type of fuel. And I alluded earlier that you have the group down here that has been looking at biological molecules for thermoresins. And so the point here that we can make is that manufacturing could occur in the US completely domestically, with 80% or 90% of the solution sourced domestically, because we have enough food stock to power bioindustrial manufacturing for many decades. And that would also solve lots of problems in other areas. And the point is that it's not necessarily that we're trying to make novel materials. We could even make the precursors. So a lot of times the waste streams, the toxic waste streams, the production mechanisms are very labor intensive and energy intensive, and biology can solve that problem to produce precursors that are then more easily converted into some of those materials. In the center here, you see that there is a healthy and vibrant ecosystem around this technology that is moving forward. And that's why Biomate is in the center there. We have the charge to really deliver on this technology through this DoD funded Manufacturing Innovation Institute. And we're going to leverage a lot of the challenges that you have posed today to really push those forward. And address those and find solutions for those in that space, because the technology already exists. So with that, I think I'm coming to my end. I really appreciate the opportunity. I have, my timer just went off. I have my contact information here. I'm happy to continue the conversation or direct you to Biomate as we get up and running and deliver some of these technologies. Thank you.